Hello everyone, me Arshia and welcome back to my channel, that is Mathematics Scholar. In this video I will be discussing about the theorem which is based on congruence. As you can see on the screen, it is a theorem number 2 and it is very important. We usually ask for 4 or 5 marks from the point of your exam. So the statement of the theorem is that two integers are congruent modulo m if find only if they leave the same remainder when divided by m. Two integers are congruent modulo m. I can write down this in symbol as a is congruent to b mod m. If and only if, IFF in this is nothing but if and only if. There is a lot of difference between if and only if. IF in the sense just if, IFF in the sense if and only if. So why I have written if and only if instead, why I can't write as if, means if I say two integers are congruent modulo m, if and only if in the sense if they leave the same remainder when divided by m, this is true. If I am considering this, they leave the same remainder when divided by m, implies two integers congruent modulo m. Two integers are congruent modulo m. Let me consider here this one as 1 and this one as 2. The meaning of if and only if is nothing but 1 implies 2, 2 implies 1. If I'm taking 1, I'll get 2. If I'm taking 2, second sentence, I'll get 1. So this is the thing, and even I can write down this one as 1 if and only if 2. Okay. So they leave the same remainder when divided by m. Whenever in symbols I'll write whenever I divide, whenever a is divided by m and b is divided by m, I'll get the same remainder in both the case. So the meaning is two integers, that is if a is congruent to b mod m, we'll get a divided by m and b divided by m, we'll get the same remainder. If I'm considering a divided by m and b divided by m, I'm having the same remainder. That gives me a is congruent to b mod m. That is the simple story behind this theorem. So let me prove this theorem. So two integers are congruent modulo m. I have made this as equation 1 and this is as equation 2. So if I consider 1, at last I should get the result as 2. If I am considering 2, I should get the result at last as 1. So this is the if and only if relation. If I am considering this, I should get this. If I am considering this, let me take a pen. If I am considering this, I should get this. If I am considering this, then I should get this. That is the meaning of if and only if relation. So let's get started with the proof. So first I am going to consider the 1. At last I should get the equation. At last I should get the second result. Okay. So what is the first consideration? What I'm going to take here is two integers are congruent modulo m. As you can see in symbol I have written here, the same thing I'm going to consider here. At last what I should get as 2, they leave the same remainder when divided by m. So this is the first thing I'm going to prove. At last I'll consider 2 and I'll prove the 1. Now let's get started with this. So okay, let me take a pen here, black color one. Okay, let a is congruent to b mod m. Okay, that is the thing I should consider, right? So then M divides A minus B. This is by the definition of congruence. I can write down M divides A minus B. Let R1 and R2 be the remainders when A and B are divided by M, then there exist unique integers A1 and B1 such that A is equal to M A1 plus R1, B is equal to B1, and I'll write, and B is equal to M B1 plus R2. So what I'm going to consider here in the sense, let R1 and R2 be the remainders. Okay, at last I'll show that these two remainders are the same. They are equal, because I should get the second one right. They leave the same remainder when divided by M. So, but before that one, I'll consider that we are getting the two type of remainder, that is one R1 and R2 when A and B are divided by M. Then there exists unique integers A1 and B1 such that this thing I have written by the definition by division algorithm. I can write down this. Okay, what I have written here, A is equal to M A1 plus R1, B is equal to M B1 plus R2. This is by division algorithm we can write down. Division algorithm. Okay, in simple words, if you want to write, it is nothing but dividend is equal to divisor into quotient plus remainder. That is the meaning of that division. I'll state the division algorithm statement here, that is for any given integers A and B, when A is not equal to 0, means A is positive, then there exist unique integers. Let me consider those unique integers as A1 and B1. Sorry, A1 and R1 such that A is equal to M A1 plus R1. Similarly for B also. So the way the division, if you want to see the clear cut of this division algorithm, you can see my previous video. I have explained the division algorithm in detail. That was my first video. Please go through it. So by division algorithm, I can write down this, where I am getting the two remainders, that is R1 and R2. Okay. So let's move on. Okay, where this one lies between where R1 lies between M, which is greater than R1 lies between M and 0, and sometimes R1 can be also equal to 0. Similarly, R2 can lies between M and 0. That is the range of those remainders. Means it can be 0 and but less than M. In between also it can be 0, and it can be less than M. It can't be greater than M. Okay, that is the range of those remainders over here. Now subtracting A minus B, I need to subtract these two. So I'll get M. Since M is common, I'll write A1 minus B1 plus R1 minus R2. Is that right? Yeah. Let me make this one as equation 1 over here. It will confuse, right? Let me take that one as equation I. Okay. Okay. Therefore, from equation I, I can write down m divides, what is there in place of a minus b here? What is there? This thing is there. So I'll write the same thing, m of a1 minus b1 plus of r1 minus r2, right? But m divides m of a1 minus b1. Yeah, it is possible, right? M is in m, it get cancels over here, so it is possible. So therefore m divides, I'll open the bracket, m of a1 minus b1 plus r1 minus r2 minus m of a1 minus b1. So but uh, m divides m of a1 minus b1, how I can write down, since m divides m. Okay, make note of it. It is very simple, but please make a note of it. Therefore m of these thing minus of m of a1 minus b1, I have written this because of this I can write down, it get cancels over there. So that implies m divides these two get cancelled, so I'll get r1 minus r2, r1 minus r2 I'll get. But r1 minus r2 lies between what and what? R1 minus R2 lies between, it is less than M. It is less than M. That is obvious, right? Because R1 minus R2, where R1 lies between 0 and M and R2 also lies between 0 and M, if I subtract these two, if I subtract R1 minus R2, then the value will be, again it will be very smaller, so it lies it will be less than m only. Therefore r1 minus r2 will be 0, so the value will be 0. Or in other way I can write down this one as r1 is equal to r2, means here r1 what is the value, we don't know. R2 in general we are proving, so at last if r1 is 4, then r2 is also 4. That is the meaning of this. So the remainder is same in both the cases. Whenever a is divided by m and b is divided by m, we'll get the same remainder. That is the thing, right? What we have taken, we have considered one, and we are supposed to prove the second one. So we have reached, this is your second one, right? We have reached. At last you can write down the sentence, therefore a and b leaves the same remainder when divided by m. Okay, that is the thing. Okay, now let us prove the next part of this theorem, that is, if I am considering 2, I should reach the 1. So what is 2 here? You can see here the 2 is, if they leave the same remainder when divided by m. They leave the same remainder when divided by m. Okay, whenever if A is divided by M or B is divided by M, we'll get the same remainder. This condition, this thing we are going to consider here. And what we are actually we should get two integers are congruent modulo M. So that is the idea of this part 2. So conversely, the meaning of conversely is nothing but the second part we are considering and proving the uh, first part. So conversely, let me write down. Let what I should consider. Let A and B leave the same remainder. Leave the same remainder R. Let me name it as R when divided by M. When divided by M. Then there exist unique integers a1 and b1 such that a is equal to m a1 plus r, b is equal to m b1 plus r. This is again by division algorithm I have written here. Since by division algorithm I have written here. So what I have considered, let A and B leave the same remainder when divided by M. Then whenever we divide by division algorithm, we can write in this form. So we have taken already that it leaves the same remainder R. So in this case I have taken R and R. This is the same. In before case I took R1 and R2 different remainders. At last I have to, it was same. Now I am going to take the same remainder, that is R and R itself in whenever A is divided by M or B is divided by M. So by division algorithm I can write down in this form. I'll write it as and this. Now subtracting A minus B, what I'll get, M is common here, so M of A1 minus B1 plus R minus R, this is 0, right? So that implies A minus B is equal to M of A1 minus B1 and 0, I don't want to write it again. So that implies by divisibility I can write down M divides A minus B. Okay, therefore, and this is by definition of congruent, that therefore A is congruent to B of mod M. Remember, M divides A minus B is an if and only if relation. This is if and only if relation where A is congruent to B mod N. So whenever this is there I can write this, whenever this is there I can write this. So I have written here that implies M divides A minus B, therefore A is congruent to B mod M. That is the thing, right? This was our first one, right? First condition. So we have taken the second one over here and we have reached to the first one. So it is 2 implies 1 only. Hence the theorem proves here. Hence the theorem. Hence the theorem. As the theorem is proved. I can write down in this way. Okay. Thank you for watching my video, everyone. I hope the proof of the theorem is clear or understood for you. Please like, share and subscribe to my channel for more such videos, and also hit the bell icon so that you'll get the notification whenever I upload my new video, and also comment in the comment section. So once again, thank you. Keep smiling and keep learning. Bye bye.